we'll take a look at another example of finding a confidence interval for a standard deviation. In the last video we looked at this example involving the ages of pine trees in the Cucamonga wilderness. In the next example, this will involve the standard deviation of wait times at Foothill Springs Urgent Care. This example is similar to exercises 11 through 16 in section 9.3. A healthcare researcher recently conducted a study to estimate the population standard deviation of wait times in minutes at Foothill Springs Urgent Care. The healthcare researcher observed a random sample of 61 patients at Foothill Springs Urgent Care and the wait time in minutes for each patient. Here were the patients' wait times in minutes, so all 61 of their wait times. In Part A, it says verify that the data are normally distributed by constructing a normal probability plot. I mentioned in a previous video that in our class we will not be covering normal probability plots. When you do the homework, if you see any part of a question that refers to normal probability plot, you can go ahead and skip that part of the question. You'll have to do the rest of the question, but it's okay if you skip any part that refers to normal probability plot, and it won't be penalized on your homework. If you are interested in learning about normal probability plots, go to section 7.3 of our textbook. So Part B says determine the sample standard deviation. To calculate the sample standard deviation, you can either use the formula or technology. If you were using formulas, you would first need to find the sample mean. The sample mean comes out to 35 minutes. And from there you can calculate the sample standard deviation, and one way to do that is to use this version of the formula. Put in all the x values, subtract the mean from all those x values, square them, so square that difference of each one, and then add up all those differences, divide that by n minus 1, take the square root of that result, and this one comes out to 12.77 minutes. So you can also use a calculator to find the sample standard deviation. These are the steps that you would take on the Casio graphing calculator, and then these are the steps that you would take on the TI graphing calculator. However you do it though, the sample standard deviation will be 12.77. Part C says construct and interpret a 99% confidence interval for the population standard deviation of wait times in minutes at Foothill Springs Urgent Care. To construct this confidence interval, you'll use this formula. Note that S is the sample standard deviation, so S is 12.77 minutes, and N is the sample size, which is 61 patients. What about these two chi-squared values? Well, since the researcher wanted the confidence interval to have 99% confidence, this means that the confidence interval will be based on the middle 99% of the chi-squared distribution curve. The values of these two chi-squared values represent the cutoff chi-squared values for that middle 99% of the curve. So one way to find these two values is to use the chi-squared distribution table, which is table 8. And we'll start by drawing out the chi-squared distribution. I've already drawn this out. So again, this is a 99% confidence interval, so that means that the middle area of the curve represents 99% of the area, or 0.99, and that means that the tails of of the curve, the left and right tail, have an area of the remaining 1%, or 0.01. Remember that alpha represents the area of both of those tails. And in each tail, it's going to be half of that 1%. So alpha over 2, in other words, the area within each tail, is 0.5%, or 0.005. To use Table 8, you'll need two pieces of information. You'll need the degrees of freedom, and you also need the area under the curve to the right of the chi-squared value. The degrees of freedom are going to be n minus 1, and so that's going to be 60. The area under the curve to the right of this chi-squared value is 0.005. So that's just referring to this area to the right. For the other chi-squared value, the area to the right is going to be 0.995. And one way to see that is this whole portion here is 0.99. This portion right here is 0.005. So the total area that's on this side to the right of this chi-squared value is 0.99 plus another 0.005. And that comes out to 0.995. Now we can start to look up these chi-squared values in Table 8. So let's go back to the drawing. This chi-squared value has 60 degrees of freedom, and the area to the right is 0.005. We'll go up to Table 8 and look for those two numbers. Here's the degrees of freedom. We'll want to go down to 60. There's 60. And up here, we're looking for an area of 0.005. That's at the very end, so 0.005. So it's going to be the last column. So we'll go over to 60 degrees of freedom. Go to the last column. And it's at 91.952. So that's the value of that particular chi-squared value. For this chi-squared value, again, the degrees of freedom are 60. The area to the right is 0.995. We'll go back up to Table 8. Here's 0.995 for the area to the right. We'll go down to 60 degrees of freedom. And it looks like it's 35.534. And below that, I've redrawn this. I've typed it out so it's easier to read, but this is the same as what I wrote up here. Now that we have these two chi-squared values, we can plug those values into the formula, put all the other values into the formula, the sample standard deviation and the sample size, simplify the inside, take the square root of both of those, and it comes out to 10.32 for the lower bound and 16.59 for the upper bound. So that 99% confidence interval for the population standard deviation of wait times at Foothill Springs Urgent Care is 10.32 for the lower bound, 16.59 for the upper bound. And one way to interpret that would be in a sentence like this. We could say, we are 99% confident that the population standard deviation of wait times in minutes at Foothill Springs Urgent Care is between 10.32 minutes and 16.59 minutes. And again, you can word this interpretation in different ways, but however you write it, you want to mention your level of confidence, you want to mention what you're estimating, and of course you want to mention the interval itself. Part D says, prior to conducting this study, the medical director at Foothill Springs Urgent Care had claimed that the population standard deviation of wait times was less than 5 minutes. Does the 99% confidence interval support the medical director's claim? Well, the answer is no. The 99% confidence interval, it does not support that director's claim. The interval is indicating with high confidence that the standard deviation of wait times is somewhere between 10.32 minutes and 16.59 minutes. And that's clearly more than 5 minutes, not less than 5 minutes as the medical director had claimed. So a couple takeaways from this section. One is that you can calculate confidence intervals for the population standard deviation by using this formula. This is the lower bound, this is the upper bound. Another thing to note is that there are no functions on the Casio or TI graphing calculators that will do this calculation for you. So for this kind of problem, one of the only choices is to use this formula. Another thing to note is that this chi-squared value, chi-squared sub alpha over 2, is the value at the right tail of the chi-squared curve, and it's the larger chi-squared value. But it goes in the lower bound. It's in the lower bound of the formula. The other chi-squared value, chi-squared sub 1 minus alpha over 2, is the chi-squared value on the left tail of the chi-squared curve. It's the smaller chi-squared value, but it goes in the upper bound of the formula. Alright, that will be all that we'll cover for section 9.3 and for confidence intervals.